In this problem, we're told on an ice rink, two skaters of equal mass grab hands and spin in a mutual circle once every 2.5 seconds. If we assume their arms are each 0.8 meters long and their individual masses are 60 kilograms, how hard are they pulling on one another? So let's go ahead and draw what's going on here. So if we know they're going to be rotating in a circle, right? So here's our circle. And so we know their arms, right? Their arms are going to reach out like this. And we know each of them are going to be 0.8 meters long. So this right here is going to be the distance. So our radius we know is 0.8 meters. And so we know the time they're going to go around, right? It's going to take them 2.5 seconds. So let's go ahead and write down what we're given. So we're given, what are we told? So we know the radius is going to be 0.8 meters, right? They tell that to us based off the arms, right? The length. So we know the radius is going to be equal to 0.8 meters. What else do we know? We know the mass, right? Mass is going to be equal to 60 kg, right? Because that's one of their masses. So we know that. And then we also know the time for one revolution. So time, 2.5 seconds, right? So one revolution is going to take 2.5 seconds. So let's think about what we're trying to find here. How hard are they pulling on one another? Essentially what they're asking is the force. And so we know the force in this case is going to be equal to m times a sub c, the centripetal force, right? Or the centripetal acceleration, my bad. So we're trying to find the centripetal acceleration. And so there's an equation we can use to solve for that. So we know the mass, right? We know the mass, but we have to find a sub c. And so we know a sub c is going to be equal to v squared over r, right? And so notice how we're given r, we know r, but we don't know v. So we have to find v, right? And so we know v is equal to distance over time. And so keep in mind they give us a time. They tell us it's going to take 2.5 seconds for us to go all the way around. So if we can find the distance it takes to go all the way around, right, for this amount of time, what we can do is just plug it in and get the velocity. So what is the distance in this case, right? What is the length, or like what is the perimeter of the circle, right? And so we know it's going to be equal to 2 pi r. The circumference of a circle is 2 pi r. So if you go ahead and do this, 2 pi, and then you multiply it by r, which we know is 0.8, it's going to give us 1.6 pi, right? And so this right here is going to be this length. And we know it's going to take them 2.5 seconds to do that. So that's going to give us the velocity, right? 1.6 pi over the time it takes to do that, which is 2.5 seconds. And so if you go ahead and do this, you're going to get about 2 meters per second. So now we know the velocity. So what we can do is plug this in, right? We can plug in 2 for v, and then we know r, and we can solve for a. So a sub c is going to be equal to 2 squared over r, which is 0.8. So a sub c, if you go ahead and do this, you're going to get it equals 5. So a sub c is going to be 5 meters per second squared. And so now what we can do, plug it in to solve for the force. Force is going to be equal to the mass, which is 60 kilograms, times 5 meters per second squared. If you go ahead and do this, 60 times 5 is going to be 300. And so keep in mind, since we're using meters per second squared and kilograms, it's going to be in newtons. So your answer to this problem is going to be 300 newtons. And so hopefully you found this useful.